Before we begin the note on the quotient rule, and before I give you the quotient rule, I do want to just quickly talk to you about this. So it says, let f of x and g of x be differentiable functions. So f of x and g of x are both functions that we can find the derivative of. Then it says, does f of x over g of x prime equal f prime of x over g prime of x. So if we take f of x and divide it by g of x, and then the derivative of that, is it the exact same as taking the derivative of f of x and dividing by the derivative of g of x? So right away, I do want to say the answer is absolutely not. And this is a good proof, I guess, kind of to talk to you about. So when I know the answer is no, or if something is trying to say disprove something, it's often easier just to do it with one example. So we're not able to prove something with one example. We have to prove it in general. But if we're trying to disprove something, it is absolutely enough for us to say, no, it is not true. Here's an example that shows us that. So in our counterexample, I'm giving you f of x is equal to x squared and g of x is equal to x. Honestly, if you chose two functions, the odds of this working out are very slim because it's not true. But I just chose these two because they're easy to derive, they're easy to divide by each other, just overall easy functions. So the first thing that I'm going to do is I'm going to write f of x over g of x. So here I'm going to change this to black. Here I have f of x over g of x, and that is equal to x squared divided by x, which is equal to x. So now I'm doing f of x over g of x prime, so the derivative of this, so that's just 1. Next, what I'm going to be doing is f prime of x divided by g prime of x. So my derivative of f of x is 2x, and my derivative of g of x is 1, and so this is 2x. So right away I could see that the derivative of f of x over g of x is equal to 1, and the derivative of f of x divided by the derivative of g of x is 2x. So right away I know that these two things are not equal, and I have officially disproved this. So now that I've showed you what the quotient rule is not, it's time for me to talk about what the quotient rule is. So f of x over g of x prime is equal to the derivative of our top function times the bottom function minus the derivative of the bottom function times the top function, all divided by the bottom function squared. To start this proof off, I'm going to let h of x equal that quotient, my f of x over g of x. And because I have this, I can actually rearrange it. So I am able to say that f of x is equal to h of x times g of x. Continuing on with this, this f of x equation, I am just going to find the derivative right now. So when I look at this, using the knowledge that I have, or using my knowledge of the product rule, I'm able to find this derivative. So we know right away that the derivative of f of x is equal to the derivative of my first function, sorry about that, times my second function, plus my first function times the derivative of my second function. Now I'm just going to use a different color here, but when I take a look at this, remember I do know that h of x is equal to f of x over g of x, so I am able to replace that in this line. So I'm going to go ahead and I'm going to say f prime of x is equal to h prime of x times g of x plus f of x over g of x times g prime of x. Now, keeping in mind our end goal is to prove this left side is equal to this right side. We did replace the left side with h of x, so really we are attempting to prove h prime of x. Now, I'm going to go ahead with that in mind, and I'm going to rearrange this last line to get h prime of x isolated. So I'm going to go ahead and I'm going to start rearranging this. So I'm going to get f prime of x subtract, and I'm just going to clean this up a little bit, rearrange these. So g prime of x times f prime of x all over g of x is equal to h prime of x times g of x. So again, I just took this last term and I moved it onto the left-hand side over here. Now, in order to get h prime of x isolated, I am going to have to go ahead and divide this whole thing by g of x. Before I do that, I am going to get a common denominator over here. So this is going to equal f prime of x times g of x minus g prime of x, f of x, all divided by g of x. Now things might be looking a little bit familiar to you right here. And now I'm going to divide both sides by g of x. And I'm going to be getting f prime of x times g of x minus g prime of x, f of x, all divided by g of x squared. Now remember, when I have a fraction divided by a fraction, which this essentially is g prime of x over 1, I am going to be multiplying by the flip of that bottom fraction, which is why this denominator turned into g of x squared. And then that is just equaling h prime of x. And then to finish this off, I can go ahead and I can replace this h prime of x with my original like f of x over g of x, which is what I let h prime of x equal in the first place. So f prime of x times g of x, subtract g prime of x, f of x, over g of x squared is equal to f of x over g of x prime. I do just want to quickly mention, again, I am not expecting you to know how to do this or to have known how to do it. As long as you are reading through this proof, listening to it, understanding the steps as I go and I talk about them, you're getting what I need you to get from this proof. Being exposed to proofs, understanding the steps as I go is all that I really care about at this point in time, especially like I said before, if you're going into university math, seeing these and understanding them is going to be important for you.